Have you ever stopped and wondered how a computer, this machine of pure logic, actually makes what feels like a smart choice? How does it decide what to show you or what advice to give, or even which way to turn in a video game? Well, today, we're going to pull back the curtain on the simple yet super powerful language of digital decision-making. Let's dive in.
So really, how do you teach a computer to think? I promise you, it's not magic. It's all about giving it a set of rules, like a logical roadmap it has to follow. In the world of programming, we call these rules control structures, and they are, quite literally, the building blocks of intelligence in every single app, game, and website you use.
To make this all feel a bit more real, let's give ourselves a mission. We've been asked by the Kenya Meteorological Department to build a simple but smart AI. Its only job? Take the current temperature and give people some helpful advice. This mission is going to be our guide as we learn the essential tools for making computers decide.
Okay, first up in our toolkit is the most fundamental of them all. It's the simple but incredibly powerful if statement. This is ground zero. This is where a computer makes its very first choice.
Think of an if statement like a gatekeeper. It's got one simple job: check a condition. If that condition is true, boom, the gate swings open and a specific piece of code gets to run. But if it's false, the gate stays shut and the program just walks right on by. It is the ultimate yes or no question for a computer.
So let's see this thing in action. We set a variable, age, to the number 20. Then the if statement asks a question. It says, hey, is this age greater than or equal to 18? The computer checks. It sees that, yep, 20 is bigger than 18, and so it follows the instruction inside and prints, you are an adult.
And that right there, that's exactly how the computer thinks. It's not some kind of human intuition, it's a strict logical flow. Step 1, check the rule. Step 2, figure out if the rule is met, true or false. Step 3, run the code only if the answer was true. It's simple, it's predictable, and it's incredibly powerful.
But what happens when the answer is no? What if we need more than just one path forward? A simple if isn't always going to cut it for the complex choices we need our programs to make. So it's time to upgrade our toolkit.
This is where the else statement comes into the picture. It gives our computer a default plan, a plan B. It's the otherwise in our logic. The computer thinks, if this condition is true, I'll do this, else I'm going to do this other thing instead. All of a sudden, every decision has two possible outcomes.
Check this out. The number is -4. The computer asks, is this number greater than 0? The answer, of course, is false. Now, because that if condition failed, the program doesn't just stop. It jumps straight down to the else block and prints negative number. The else acts as a safety net, making sure there's always an action to take.
Okay, but life is rarely just two choices, is it? What if we have 3, 4, or maybe even 10 possible outcomes? Well, that's where elif comes in to save the day. It's short for else if, and it lets us chain multiple checks together, creating this awesome ladder of decisions.
Let's imagine we're building a program to grade an exam. We've got several possible grades, so a simple if-else just won't work. We need more options. This table right here shows the exact logic our code is going to follow.
Now, this part is super important. Here's how the computer reads this. Our marks are 65. It asks the first question. Are the marks 80 or more? Nope. So it moves to the next rung on the ladder, the elif. Okay, are the marks 60 or more? True. It prints grade B, and, this is the key, it stops. It found the first true condition, and its job is done.
All right, we can handle different paths. Now, let's level up and make our conditions even smarter. We can actually teach our program to check more than one thing at the exact same time using something called logical operators.
These three little words, and, or, and not, are like superpowers for our code. With and, we can check if a person is both an adult and under 25. With or, we can check if a delivery is going to either Nairobi or Mombasa. And not just flips the condition on its head, letting us check if a user is, say, not logged in. This is how we start building some really complex and realistic logic.
All right, our toolkit is officially complete. We've got if, elif, else, and our logical operators. It's time. Let's put it all together and finally complete our mission for the Kenya Meteorological Department. Let's build that weather AI.
Here's our rulebook, the AI's instructions. It needs to give a very specific piece of advice for 4 different temperature ranges.
This is a perfect job for our if, elif, else structure. Each one of these bullet points is about to become one step in our decision-making ladder.
And here it is, the code that brings our AI to life. It starts right at the top of the ladder. Is the temperature less than 15? No? Okay. Then elif. Is it less than or equal to 25? Still no? Okay. Then elif. Is it less than or equal to 35? And if none of those are true, the else statement is there to catch everything above 35. It's just a clean, efficient cascade of logic.
So let's imagine a user types in 32. The code runs its checks, finds that 32 is less than or equal to 35, and it assigns the correct advice. And just like that, our program speaks. It gives a helpful, intelligent response based on the data we gave it. Mission accomplished.
So, we did it. We built a decision-making tool from scratch. But you know, the most important part here isn't just watching me do it. It's realizing that you now understand the logic. You have the tools to make a computer think.
So let's do a quick recap. The big idea is that if, elif, and else are like the traffic cops of your program. They direct the flow of logic. They let your programs make smart, conditional decisions. Then you've got your logical operators, and, or, not, which just make those conditions even smarter. And as we saw with our weather AI, this isn't just theory. This stuff solves real problems.
Okay, now it's your turn. Here is your first challenge. Take everything you've just learned and build a program that categorizes a person's age. You have all the tools you need. An if, else ladder is absolutely perfect for this. Think of it as your first step from just learning to actually creating.
Because really, that's what this is all about. These tools, they aren't just for grading exams or checking the weather. They can be used to build a game, to analyze data, to automate some boring, tedious task, or to create something brand new that no one's even thought of yet. So the only question left is, what problem will you teach a computer to solve next?